All right, good morning, or afternoon now. Thanks everybody for being here. We're gonna go through a few items today. Gonna go through a little bit about PG&E, then we're gonna go through, we rolled AUD out, and we're gonna kind of go through some of the rollout, some of the enhancements that we did. We're gonna have a little demo, so I know everybody likes to see how utilities are using it. So we're gonna go through a little demo, and then we're gonna go, where are we going in 26? So some enhancements and those items. So, all right, I'm Tom Copeland. You guys heard me earlier. I'm senior manager for the design team. We have Jason Evans here, Andrew Bila, Mark Jensen, and Yannick, and I'll butcher Kovalenko.
Pretty close.
Okay. They'll give a little more background. Each of us are going to kind of talk through some of the topics. I'm just going to cover the very basic one of PG&E and kind of where we're at. So just a little background, PG&E's service territory is about 70,000 square miles. We serve just over 16 million Californians. We have 28,000 employees at PG&E. In our service territory, we have almost 107,000 miles of distribution line, both overhead and underground. We have about 18,000 miles of transmission line, 42,000 miles of distribution gas line, and almost 6,500 miles of gas transmission line. We have an annual spend budget for maintaining our territory about $40 billion. As part of our design team, we have about 986 electric distribution designers. We have about 713 contractors that support us also. On the electric transmission side, we have about 135 designers and about 212 contractors. We have 192 distribution gas designers and 34 gas transmission designers. We also, on our distribution side, I mentioned earlier, we have 13 design centers spread out through our territory. In 2024, a lot of you probably heard or had seen, we made a really big initiative. The company made a decision due to our high fire threat and wildfires in California. We made a commitment to underground 10,000 miles of our highest threat overhead lines. So last year we undergrounded we designed about 401 miles of underground and 146 miles of overhead hardened. This year we've done over 396 miles to date and 288 miles of overhead. And to date, we are over 800 miles that we've put underground, we've actually installed in the ground. So, and we're on track next year to do just over 400 miles. That's going to be our biggest lift. This year we're doing 310 miles of underground. Next year is going to be our biggest year of 400 miles. So, a little background of our old tools that we used to use. We are currently in AutoCAD 2021. Currently this year we'll be migrating to 2024. We do use SAP. We use, for our pull loading calculations, we use OCalc, and then we have ArcGIS Esri for our maps and assets. We also use a custom tool that is a front end to SAP. It's called EES. It's our materials. It is a manual tool in the past that we would have to go in there and manually order all the materials for all the locations. We also, all of our calculation tools were an Excel-based and manual. All of our pulling calculations, our volt, drop, and flicker calculations, all of those we did by hand. So with that, I'm going to hand it over to Andrew, and he's going to go into our future rollout, our current rollout.
All right, hello everyone. So as far as PG&E is concerned, I'm sort of the point person for our AUD support team. In between Mark and myself, we manage the AUD template. So talking about our AUD deployment timeline, we started this effort back in 2023 And we had originally targeted a date of June 2024 as our go live. As things progressed, we decided to postpone that go live date to October of 2024, and then we scaled back that go live so that when we did go live in October, there were only the 4 SMEs working in production in AUD. Since that point in go live, we trained 48 people through the months of January to June, and then starting in June, carrying on for basically the rest of the year, we trained 24 new people on AUD. So up to this point, we have about 96 people trained in AUD, and I stress the word trained because we developed AUD for system hardening work, but our system hardening work is highly dependent on rate cases being approved, base maps being provided. And so at this point, we probably only have about 20 people actively working in AUD. We expect that to ramp up significantly in the next month or two as all of those base maps are collected for our 2027 planned work. Between the 20-ish people that we have working in production, we've completed 13 jobs. And while that doesn't sound like a very imposing number, also bear in mind that these projects are generally larger in scale. The smallest one was probably about 1 mile, and then the largest one I think was 3.5 miles replaced. So small number, still a lot of footage replaced amongst them. We presented last year kind of on what AUD we thought would look like at PG&E, so I didn't really want to sort of rehash those things, but I did want to sort of talk about the configuration process, and if we were to do it again today, what we think we would do a little bit differently. So these are some of the key drivers to that go live date delaying a little bit. To start us off, we have some pretty rigorous CAD and permitting requirements. We were an AutoCAD shop, and so sort of the prevailing thought was we should be able to match with AUD what we're used to seeing in sort of our non-AUD design process. We have some pretty strict municipalities, especially considering we're almost exclusively underground work. That meant that there was going to be a lot of scrutiny on these jobs. And so there was a lot of work making sure that what AUD produced would be high enough quality, get through permitting, so on and so forth, and again, sort of match what we were used to seeing outside of the AUD process. In hindsight, I think we would probably look at that and say, well, maybe we should spend a little bit less emphasis specifically on underground and spend a little bit more time developing the overhead. But I guess that's the power of hindsight. The second point, a lack of standardization. Again, AutoCAD shop, so we did have a little bit of foresight here, and so before AUD entered the picture, we did go through the efforts of putting together CAD standards. So before AUD, again, was in the picture, we didn't necessarily have to discuss things like color and line type and line weight and all of that stuff, because we had a document that spelled all of that out. However, that was really just limited to sort of the finer aspects of a CAD file. We didn't have what I would refer more to as like a design standard, sort of, giving guidelines on how like an overall design should look. And with that being said, we have 13 sort of major design centers, and amongst those 13 design centers, we have probably 3 or 4 ADEs in those design centers, and those ADEs are who are responsible for reviewing these projects. Which means that we have about 50 or 60 different people responsible for reviewing these designs, which means we really have 50 or 60 different sets of standards that are not documented anywhere. So we spent a lot of time, again, focusing on a high quality AutoCAD design, but also had to consider all of these things that one office was doing it one way, another offices were doing it another way. This ADE in this office was even doing it his own way. So there was a lot of time that we spent PG&E to PG&E just talking about how this ends up needing to look. And unfortunately, a lot of that conversation happened with SBS in the room when we could have been talking about, maybe more relevant discussions to what needs to happen. Third bullet point, we developed it for a specific type of work. As I mentioned, we developed it for undergrounding. And then as things progressed, I think PG&E came to the realization that undergrounding is really, really, really expensive. And so the focus of the system hardening project shifted from underground only to some undergrounding, but a lot of overhead hardening. And early on in the configuration process, we really hadn't paid any attention at all to anything overhead, because again, it was being developed for underground hardening. So we spent a lot of time, even post-deployment, trying to get everything to where it needs to be to work for our overhead hardening. Bullet point number 4, dynamic assembly builder. I know a lot of people have mentioned in their presentations that materials have been a pretty common pain point. And I'm going to reiterate, materials are a huge pain point. We have what's called the dynamic assembly builder, I'll refer to it as the DAB, and that sits inside of EES, which is, again, inside of SAP. And the dynamic assembly builder is essentially how we go from a feature to CUs. And to give you a little bit of context, it looks kind of like an online shopping cart, more or less. You would go into EES and you would say, I want an overhead transformer. And then you would be prompted to answer a bunch of questions so that it could drive down to the CUs that were relevant to the transformer that you needed, or the CUs that you needed as part of that transformer installation. And huge shout out to Sarah and team for being able to take what is essentially a completely PG&E custom thing and find a solution for that to happen in AUD. We essentially had to mirror the logic in EES to make it also apply in AUD, which is a huge undertaking. There were a couple of big pain points related to this one bullet point, though. Number one is that this is constantly evolving, these dynamic assemblies, right? We're in most of Northern California, we have coastal areas, we have rugged, hilly areas, we've got all sorts of different environments and climates, corrosion districts. And so these DABs are always changing, and they're owned by a team that wasn't probably as involved as we would have wanted them to be. And so it was like trying to hit a moving target. I remember Sarah a couple of times showing up saying, hey, I had this working, and now it's not. And then we'd go and talk to the team that owns these and be like, oh, well, they removed the little foot marker from pole height, and it just completely broke our logic. So it was a moving target. Number two, the user interface is a lot different for EES or the DAB than in AUD. And so specifically with overhead framing, they didn't have a very rigorously built out dynamic assembly that worked in AUD. When it came specifically to overhead framing, they would do a primary framing DAB, but then there would be a lot of manual manipulation to get exactly what they needed. They didn't have sort of a nice, clean, orderly DAB like we see with other features. So we basically had to recreate our own DABs for all of the different overhead primary framing scenarios to be able to drive to what we needed to. It's still a work in progress even to this day, but we're getting there. And then last, and I would say maybe this is one of the most important points, is our own lack of understanding when writing requirements. I looked just the other day at our defect list, which goes all the way back to the beginning, and we had 110 defects or enhancement requests related to callouts. And I have to think that a lot of that is because specifically with something like callouts, there's maybe 20 different scenarios that might determine the contents of a callout. But as we were sort of learning how AUD functioned and worked, we didn't really grasp that immediately. So we would write a defect that said, oh, well, this pull callout needs to read, pull height, pull class, depth of setting, and then, the configuration team would do what we asked them to. And then we would get the build, and then we'd look at it, and we'd be like, well, that's not quite what we wanted. We wanted it in maybe this scenario and this scenario, but not this scenario. So anyway, there was a lot of sort of redundancy and rework because we didn't really know how to phrase these enhancements or defects or change requests in general in a way that would really be successful while limiting rework. So with those sort of pain points, we have some lessons learned here. So again, with the power of hindsight, we would have had a greater emphasis on overhead design from the beginning. I don't know that there's any way that we really could have known that at the time, but it really would have saved us a lot of the struggle that we're going through right now if we had done that. Created additional standards before implementing AUD. I think this is probably something that everyone in this room is could probably agree with, right? We didn't really understand everything that would have to be standardized for AUD to work. Again, callouts being a good example. If you look at the drawing, 10 different drawings, there's probably 11 different ways callouts are being done throughout our different offices, and all of that discussion had to be done. Had we done a lot of those discussions more internally, and so we had more of a solidified change request that we could send to the configuration team, we would have saved ourselves a lot of time and hassle. And sort of to help that as well, if we had had an internal support team member that had gone in and to some extent had understood the AUD rules and how they got applied, they could sort of act as a filter so that any change requests that we wrote had the level of specificity that would be required to, implement it well. And along the lines of change requests, we should have had better parameters on the level of detail that those change requests needed to make. Again, most easily probably done by having someone familiar with the rules who could sort of act as a filter for those enhancement requests so that they would make sense and Sarah didn't have to get mad at us because they had to guess basically at what we were intending. And then last but not least, define, train, stabilize the group before implementing AUD. If everyone was working in the same way to begin with, then having a tool that enforced it to be done that way would just make things go a lot smoother from end to end. All right, now I'm going to pass you to Mark and Yannick, who are going to do some live demos on some of the highlights that we found from using AUD.
Do that slide first, right? Yeah. So before again, I'm Mark Jensen. Andrew kind of stole some of my thunder. He just about covered everything that we've done from beginning to end. But so the first bullet point is standardization of designs minimizes customizations, and for a lot of reasons he described. What happened? Did I just lose my notes? Oh, here we go. Added a page. Okay. So Tom probably said it a couple of times. I'll reiterate. We have multiple design centers that lead to silos. I heard the word silos this morning, right? And that means we have unique design practices. Even though they're the same company, we follow the same standards. We have the same book of standards. We have some that do their own designs to create efficiency, some who actually do it just to make it pretty, and some who do it that's because it's the way I've always done it. So we have to get over that. It was one of the things we had to get over. As Andrew said, we did create a new template structure, I should say, for AutoCAD for large projects. That gave us new layers, new colors, new blocks, in the idea that we had AUD in mind, that we were going to do AUD, and so we wanted to get more efficient and more standard and consistency. We use the term callout now because of AUD. We used annotation before. So with AUD now, we have rules that drive the annotation from attributes instead of text that a different designer would put for each line, or which rotation they would do, or how they would describe a certain block. And then now we're going to utilize layers and line types that Andrew has created in the template for specific requirements that we want to enforce. So voltage drop, flicker, and rise calculation, as Tom said, initially we do that in a separate tool. But having fully connected features with the necessary attributes will automate those calculations for us. And we have actually in the ability in AUD to set up rules and to make those calculations better than the tool we were using before, because it had limitations. Like, for instance, our residential tool is only single phase. It doesn't do three-phase calculations, which we can actually set up rules in AUD to do for us, which is huge. I'm going to combine the three bullets that we see there. Why can't I get this to work? I'm going to combine the 3 bullets that we have, if I can get my computer to work here. So material integration to EES and SAP eliminates overprocessing of materials, the ability to output tabular material takeoffs for long lead, and the design tool drives the DAB, or Dynamic Assembly Builder, to generate the correct CUs or compatible units. So Andrew actually, it's almost like he looked at my computer and said, you know, we have to give a great shout out to Sarah Jones and to Joe Gonzalez for actually asking during the requirements process, how do you guys do your work? What do you do? And Rod Wetmore's not here. He was a part of our team. He's retired since then. Really emphasized, look, we have a structure in, EES stands for Enterprise Estimating Solution. It uses UI5, which grabs SAP data tables and does all the cost calculation via function models in SAP for cost and materials, overheads, all those things. And you know I asked about costing yesterday. We don't expect to use costing in this tool. The idea was maybe more to have a gross cost for each CU and try to summarize things. SAP does everything for us. It's going to continue with SAP for HANA to do everything for us, maybe with less customization than we have right now, but we're prepping for that. So AUD now utilizes our existing method that we used to do CUs. And the DAB, Dynamic Assembly Builder, really is for multiple CU selections. So we actually create a dialog box with classes in it that have different question and answer sets that say, if I have these particular questions, here's the CUs. If I answer them that way, that I'm going to get. And they match that in AUD using the feature and model attributes. So we set up a model and the feature attributes and model attributes to help drive those question and answer sets so that we get the CU selection that we would if we were in our EES tool in SAP. The way they do that, I mean, currently we do that from user entry, right? It's manual entry. And it also assumes that the user is going to go to our standards, look at what the information from the standards that they need, and make the correct choice in that class to get the correct CU. A lot of that is now embedded, following the standards in AUD because of the rule sets that we have. So we've taken what was a manual entry for CU selection, and now we've made it a design process. So when you pick the correct model for your design, you've actually done all those entries because the model, the features, attributes, and the model attributes drive those question and answers, so the accuracy goes way up. It's less chance for you to make an error in getting the CU selection. Let's see, was there anything else I had here? I would say, as Andrew brought up, AUD's had us change the way I actually write the DABs now for our EES tool that are specific to AUD. The reason is the other DABs were set up for a user interface. The person was making decisions based on what they had for knowledge by looking at standards and their current design, where we don't need all those questions and answers necessarily. We need only ones that are specific to the attributes for the features and the models that we're installing. So we've limited some of the answer question sets to make the actual CU selection more efficient, and AUD is the reason. There was a bullet point there about materials and using that to try to do takeoffs for long lead. We're utilizing the export function from the materials report 2 ways. One is we can get a list of CUs in that design, but also we're putting it in Excel so that we can organize it, filter. So those people that review the design, they can use the existing review process they have in the EES tool and compare it to what they have in EES. Does 2 things. One, it gives them the idea that I have all the CUs I need in my AUD design, and at the same time, it matches what I need in SAP for that design. So it gives the comfort level to that reviewer that AUD is actually working the way we need it to work. It's getting the CUs that we want to. In fact, it's getting, in the future, maybe more CUs than we would have been able to get in the past. And I think that's about it. I think now we're ready to go to a demo for, yeah.
So, check. Good evening, everybody. My name is Yannick, and I am one of the SMEs at PG&E. Let me try to share my screen. Might have to drag it off. So, I was asked to do a demo. I was also given a job, so I figured why not do the actual job while you guys are here. So I'll have you here for roughly 6 hours. I think I should be able to knock it out. I'm kidding. So all that sounds great from the configuration side. As far as on the designer side, what did that mean, and how do we utilize AUD and some of the key features that we found? Some of the benefits where it saved us time, it saved us effort, it saved us clicks. It basically automated our workflows. So I'll just share a few things. I won't take up too much time, but some of the benefits that we've found are from the GIS import. So in the past, we would go to our GIS services and create a polygon of what we want to export or import into our CAD file. We would get a regular CAD file in our email, roughly 5 minutes later after we've requested for it. And you could tell that these are just, for lack of a better term, dummy blocks. So they don't hold any attributions. We would have to manually type that it's, well, some of the text is there. It's a 2525 kVA transformer. This is a partial CGC number here. It's attached on the 50-foot pole. There's no class assigned to it. You have a meter block, which the little square that I just highlighted, that's a meter. There was no loading data in the CAD file itself. We would have to go to GIS, figure out the load that is on that meter, know that it's connected to these transformers, and kind of work our way through. All of the callouts that you see, they're all just MTEX dummy blocks that an estimator would have to then clean up, rotate, I would imagine much like everybody else is doing. So with AUD, we're able to, and here on this drawing, we're able to overlay our GIS directly into our CAD file, our live CAD file. And so if we wanted to import any facilities, we would create a polygon around our facilities that we would like to import. I won't do that now to save time, but we would draw a little polygon around what we want to import, hit enter, and those facilities that I draw a polygon around and everything that's attached to it would get imported with the model-based features and attributes. What that looks like, it would look something like this. I've imported a different area just to demonstrate what it would look like. You can see that as soon as we select anything, it's a featured, it's a model, so segment. We've got our conductors, our pre-configured conductors, cables, anything that we select have a model associated with it. But more importantly, we get, on the transformers, we get the loading information. On the meters, we no longer have to go back to GIS, pull up the loading information. Within the attributes, we have our load, our power factors, and things like that. We would still have to specify a climate zone that we're in, display our volt drop flicker, and make our connections. So there would still be cleanup work. As you can see, our conductors are not connected to poles. We would have to establish those connections. Some of the things that GIS did not have enough information, like services, to know what type of service it is, we would still have to make those cleanups up front. But once that is done, that kind of lays the foundation for our design. Having all of those connections done, having everything connected properly, we're able to then leverage the models to extract any information that we need. So one of the huge benefits that we've seen are the pulling calculations, volt drop flickers, generating tables, and so pulling calculations. In the past, we would have to use an Excel spreadsheet, much like Tom had mentioned. We would have a spreadsheet that would look something like this. We would have to specify the cable that we're using. We would have to specify each section. So to kind of explain why the benefit, we would have to come to CAD, explode our lines, list it, figure out, hey, this is 8-foot section or 9-foot section. We would put it into our Excel spreadsheet. It's a 9-foot section, and then it's got a 45, then measure another section, it's another 45, and therefore build out our cable pulling, which at the end would spit out the result of the tension and preferred direction and reverse pulling direction. We would then copy this data and put it into our tables. This is what our cable pulling tables would look like. This was a job, a fairly small job, I would say. And you can see that we have 43 tables that we have to fill out. That means that we would have to have 43 files with multiple entries to figure out our cable pull. We then would have to fill out all this data manually, go back to the drawing, figure out the length of our cable with tails, put it in here, and kind of work our way through. I would imagine roughly it would take 2 to 4 hours if there was no changes. And then you go out on the 30%, you do a walk down, construction decides we're now gonna put a transformer here, we're gonna move it to the other side, and you're back at it changing all of your calculations. So with AUD, which was a huge benefit from the designer side, we were able to generate our cable pull automatically. So our tension is automatically being calculated. Our conduit length, plus we have rules that are written. If you're connected to a pad-mounted transformer, these are the tails for the cable. And if you're to some other piece of equipment, these are the tails. So the second number displays the tails, and then you have your tension. As soon as we were to move something, that automatically gets calculated and changed. So for example, right here at location 4, has 721 foot of conduit, 766 feet of cable, and that's the tension, 950 or 9,574 pounds. If I was to move something just for demonstration purposes, AUD will recalc, it will run through analysis, figure out whether I'm exceeding bends. We're not even talking about validations, but it would run through validations of, hey, are you pulling more than minimum required length? It would run through all the validations, run through the calculations, and update our conduit length, cable lengths, our tensions, which would also be in the preferred direction, and reverse tension as well. So we made that change without doing anything manually. We got updated information at location 4. So then we started thinking, okay, do we still have to fill out the tables manually? With a little bit of brainstorm back and forth and Andrew's help, we were able to generate some tables. So we wrote a little, I would imagine, script. I'm kind of outside of all that configuration. I'm not smart enough like these guys. But we were able to create a AUD table that would allow us to basically fill out those tables that would take us 2, 3, 4 hours within a couple seconds. And some of the information that were not previous on the other tables are like from what location to what location, which is super beneficial. And then we're able to also record the preferred tension as well as a reverse tension. So that way, when construction calls us, hey, we're actually going to be pulling in a different direction. Well, they have all the data that it still passes and whichever direction they want to pull. In the same way, we would do our transformer tables. So volt drop flicker, we would have to create, run through Excel spreadsheets, fill out, this is what they would look like, fill out the transformer sizes, single phase or whatever the voltage is, fill out how many customers we've got, fill out the lengths of our secondary lines as well as services to our secondary enclosures, and then that would spit out information of volt drop, whether it's meeting volt drop, exceeding volt drop, and so on and so forth. And you can imagine this would have to happen at each transformer, and you would have to fill out all of these different branches depending on which way the secondary or service is branching out of the transformer. Same idea with AUD. Basically now, since everything's automated, we're able to select, I'll just pick this location here. We're able to automatically display our volt drop flicker because we have the load on our meters. We know the load that's being applied to the transformer from the meter. And as soon as you move our service, or let's say a meter, in this case the meter is attached to the pole, so I'll move the pole, and you can quickly see that the volt drop automatically updated, flicker updated. If I wanted to and you can see also on my transformer total load as 19.9 kVA. If I was to simply update the load on the transformer, on the meter, downstream it sends that information over to the transformer, and validations are being ran, so let's just put 8. Calculations are being ran to validate whether that transformer can handle that load or it needs to be upsized, downsized, and so on. My computer froze for a second. But so we changed it to 8 kVA. We would resolve our transformer, and as soon as we resolve the transformer, you'll see that ESD goes up because there's more load now being applied on the transformer, which that didn't happen, most likely because it's a live demo and connections didn't happen. And you guys are all watching. So those are some benefits. There are plenty of more, especially as Andrew had mentioned, standardization of our callouts. So all of the callouts are kind of being driven on the back end. So an estimator or a designer can't go in here and change the callout how it would look like. As soon as they would, if let's say you dropped in a transformer into your drawing, they don't manually have to type anything in. All the callouts are kind of pre-configured off of the models. You would simply select anything you want to make a callout of, create, insert callout, and all the callouts are pre-configured, so they don't have to fill out any information manually. There are some entries that they would have to do, like transformer name, the CGC numbers, and that's pretty much it on the transformer, and it would populate your callout automatically. Same idea goes with anything else, our cable callouts or conduit callouts, any piece of information that we're creating a callout, we try to create an automated callouts for it. And another huge benefit, I don't know how much time I was given, but another huge benefit is we have
6 hours.
Oh yeah, that's right, 6 hours. We had to create a single line diagram. We call it circuit sketch, also known as a one-line diagram. We would create those as a separate drawing. So we would have our design. Oftentimes we would create those drawings beforehand. So with AUD, we're able to basically, whatever design we have, without doing any extra steps, without any redrawing your drawings, select single line diagram. This takes a little bit longer because it would try to select everything that you've selected, specify the base point, and you're able to generate a one-line diagram, which I'll show you in a second, within, I don't know, maybe a minute, when it would take us 4 or 6 hours sometimes to create single line diagrams. And again, if those would change, you would have to go back to your single line diagram, remember to update any changes on your drawing, and then the single line diagram. And again, my computer froze for a little bit. But both of those are all kind of tied together, meaning if you were to change something on the construction drawing, one line diagram gets updated automatically, whether you're changing the size of the transformer, changing the size of your conductors, or anything of that nature. And you can see right here, simply with a few clicks, I've regenerated my one line diagram. We're still making improvements on it to make it better and more user-friendly, but with a few clicks, I was able to create a line diagram that would take us hours and hours.
Schematic for our circuit design.
Correct, schematic. There's plenty of more to talk about, but I'll pass it on to Jason.
I think it's Andrew.
Or Andrew to finish it up.
Kind of wish it was Jason, then he'd have to figure out how to switch us back to the PowerPoint.
We're just gonna move it.
Oh, there we go.
That's
Now, one of the biggest things is we get a lot of calls from construction, they're out in the field, all of a sudden they run up the mountains, they hit a big boulder. Hey, I need to move this transformer 30 feet. We would have to go through, do all those hand calculations, and figure out if they can move it 30 feet. This, it just goes in, moves it, recounts, we can let the crew know right then and there, we're good to go.
Would you mind repeating that just for those online?
I was occupied.
So, so basically what Tom said is oftentimes we would get requests from crew, hey, we are going to be shifting our transformer 20 feet, 30 feet downstream, or any piece of equipment is being relocated to a different location than what was originally designed. So construction will call us and, hey, confirm whether that change or that move is allowed based on our standards, whether we're going to exceed our bend angles or tensions. So we would have to run the calculations again on our side, run through spreadsheets, update the drawing, tell the construction, yes, it's good to go. And with AUD, now we're able to not necessarily skip all the manual calculations, select your model, move it, and it would update the calcs and immediately tell us whether it's a good to go change or not.
Thank you. So what I just wanted to highlight one more enhancement or highlight that we didn't explicitly.
He should have just done the whole thing.
I was working with a user the other day, and he was installing a long 6-inch conduit with, I think, 3 million cable or something in it. And he was in sort of a rural area that had a road that sort of zigzagged from beginning to end. And he had designed it to be at about the 800-foot limit for vertical bends on either side. But he asked me, he's like, hey, I think I'm getting some weird pulling tension numbers. They're way higher than I think they should be. And we started looking at it, and we realized that AUD was doing what it was supposed to do. The other ways we have of calculating pulling tension, they don't take into account field bends. And because he was following essentially sort of the layout of the road, he had quite a few field bends from one end to the other. They were, 50-foot radius bends, but over an 800-foot length with million cable and 6-inch conduit. AUD informed us that what we would have otherwise looked at and been, hey, this looks okay, because it is it's much more granular in its calculations. We were able to identify that, hey, this is actually problematic, that we wouldn't have been able to flag otherwise. So I thought that was a pretty cool highlight.
Well, I would add, so in our spreadsheet that you saw Yannick show, some of those, we call it roping or field bends, where we're just bending in the conduit. That tool would have seen it as a straight section, where AUD actually sees it a physical bend and gives us the sidewall pressure, everything that tells us this won't work.
All right, so we're going to shift gears just a little bit, talk about the AUD support. And I can guarantee you that our AUD support is structured better than this slide because I'm going to start at the bottom. So we have 4 of us that are dedicated to supporting AUD. 3 of my coworkers who are not here right now, they're sort of the primary point of contact for user support. Yeah, we're going to use sort of the local SME model that a couple of other groups had presented, I think, last year. Identifying a couple of SMEs in each office. Obviously, with sort of our staggered rollout, we're a little bit slow in developing that structure, but hopefully we get there. And then as far as the configuration, it's myself and Mark here, who shows up orange because he's technically on another team, but he is every part is important for the configuration as those in blue.
Checks in mail, pal.
As far as how we are supporting our AUD users, we took a lot of notes last year. And again this year mentioning the OneNote as a great place to provide information to users. We have a Teams and/or a SharePoint site, however you want to look at it, with additional documentation on AUD use. And I think all of those things were highlights of a lot of the groups that presented last year at the PUG. Additionally, we have what we call daily office hours, so from 2 to 3 every day. Anyone who is an AUD user can join the call. They can bring up issues. Sometimes we'll plan demonstrations on how certain functions work in AUD. So just sort of grassroots trying to share what we know about the tool with those who may not be as well versed.
Can you talk about where you teams into an individual designer and help them with their, because that's a huge support role too.
And Microsoft Teams is great. I don't know what they would do without it, but a lot of times when users have issues, being able to essentially look into their machine and see what they're seeing has been pretty instrumental. Again, I don't know how the world survived without it. Real quick, some suggestions for AUD. I had heard that past years this was a pretty common slide, but it dropped off. So these are just a couple of suggestions that we've had when using AUD. So number 1, obviously this is going to be a little bit more towards those who are administrating their configuration, but step through debugging for rules. So make it easier to debug large rules that maybe you want to, sort of go slowly through the rule to find out where your problems are. Also, work location blocks and callouts, if we had the ability to place those as multi-leader objects in AutoCAD, I think they would be a lot more functional. Currently, the way to place leaders on blocks or callouts, what I hear from the users is basically it's so clunky that they don't use it. So if they were natively as multi-leader objects in AutoCAD, they'd be much more functional. Connection highlight, I called them modes for lack of a better description, but essentially the ability to check connections of a specific type. So for example, like electrical secondary, one of the most challenging concepts for people to understand when transitioning to AUD is connectivity. And the current highlight connection tool isn't granular enough to be very useful. So if we could program in these modes where you just highlighted the secondary network so they could identify where voltage drop and flicker breakdowns are happening, and make it, I think, much more functional and usable to our users. And then I had a couple other ones that I'd come up with. I'm going to see if I can remember them in front of all of you. But maybe I'll wait until Jason presents and see if they come to me.
So much time you have.
Yeah, so I'll pass you to Jason.
Okay. All right, so my name is Jason Evans. I'm a program manager supporting innovation projects for PG&E, mostly for underground specifically, but also outside. I'm just going to talk about the future of AUD and what we have planned for somewhat of this year and next year. As you see on here, we're actually, and I think Tom mentioned it too, we are moving to AutoCAD 2024, and then we also intend to, with Sarah's recommendation, upgrade AUD as well. Right? I'm just kidding. We also plan to train another 400 users. We'll be at about 400 plus users next year. And then we also have trained contractors as well. So our user base will expand within PG&E quite a bit. We also plan to do 400 miles of underground next year designed, and 150 miles of overhead. So, and that's all planned to be done in AUD. And we have some we just kicked off an enhancement project this year, which we probably won't realize the benefits of until next year. But some of the key things that we're going after is like, we have it on here is incorporate 3D mesh. I mean, really that just means we're gonna actually start drawing in 3 dimensions. So we're actually gonna be laying conduit undergrade. Same thing with pole heads, right? So we're actually setting poles at their actual elevations. Now that unlocks a lot of things, and it's actually a prerequisite for some of these other things, right? So we're gonna start getting into like overhead, sag and ground clearance calculations being automated within AUD. Same thing with underground polling, cable polling, for example. I just got a call today about a scenario like this, right? So I'm going down a steep cliff on a drawing, it's only 40 feet long, but the actual cable pole is much longer than that because of the elevation change, right? And they're probably gonna have to tie the cable so it doesn't slide right through the conduit. So it presents all kinds of unique situations that we'll be able to identify within the tool. Also, it allows us to get into what has been an ask from like Caltrans, and people, if there's anyone in here from California, don't think so this time, but we deal with Caltrans. They have specific requirements for the drawings that we deliver to them for permitting. So one of those is section cuts of the roadway, understanding where a trench is next to curb and gutter, next to the right-of-way, or center line. They're also looking for plan profile drawings, which are not typically done in distribution, but gas transmission, very common. But that kind of functionality isn't native to core AutoCAD. So we're gonna start digging into those. Trench model enhancements, so really we're trying to get into, trenching is very important to us, so we've identified that, of course, the majority of our construction costs or even project costs are civil construction. I don't think that's a new idea, but so we're looking at any way that we can to minimize cost of construction. So one of them is really just around dirt displacement and management. So if we can model different trenches in different ways, then we can actually run different cost models and better understand our spoils management and get ahead of planning, right? And really even just, running scenarios through AUD in which we reduce a trench width by 6 inches but have to go deeper. Now volumetrically, that's reducing spoils. Now take that through 5 miles, how much of an impact are we making? So we want to get to a place where we can automate some of these things, also with occupancy, right? We have our own gas, we have our own fiber. We also have third-party utilities that are sometimes hopping in, sometimes not. So we need to be able to break those costs out. Now we have a very complicated way of doing that. It's pretty fair, but it's very complicated. So we're trying to find ways within the tool that we can not only better understand and automate how those trenches are being configured within the excavation, but also the cost breakdown of it, being sent over to SAP, where we kind of handle the rest. And then as far as enhancements, as far as UDH, so we've already built the integration with our own GIS to bring in asset data, but we want to kind of expand that because we have there was another project that I kind of presented here last year that was a thought, and it's actually come to fruition now. So our planners are actually putting the asset plan in GIS up front now. We want to be able to bring that asset data in and model it, and then create a design, and then downstream of that, we still have a lot of things to do. But the concept is really just having GIS be the single source of truth throughout the project life cycle, cradle to grave, right? In order to do that, we need to have this automation built in. Some of the non-asset stuff that we want to bring in is things like easement acquisition polygons and updated status of these easements and acquisitions, and environmentally sensitive areas. So we have a lot of this data that could be provided very, very early in a project. We want to bring that in and use it, or write rules around it. And geotech is another one that we've been playing with. the concept of like bring in geotech, we have a polygon for this type of rock, can that inform either my MOI or my cost or just effort, level of effort? And can we run models off of that? Like it can, taking different routes or whatever. So I think that's probably the last one in the GIS interface that we're going after. But then we also want to explore push capability to mobile design, basically. So we can either view it in the field, make comments, like, I want to move this box, but also unlocking the capability of mobile as-built. So that's kind of where we're at today.
Environment switching, thank you.
Environment switching. Oh,
Remediation
for UDH, yeah. Well, we didn't do that, they did that.
No, but
Yeah,
we're gonna.
yeah. But yeah, so then I guess we'll just open it up for questions. Not yet, no. So we have two technology projects running parallel right now. One of them is moving to UN, the other one's S4HANA. Yeah.
I was surprised to hear that segmenting things out into underground workflows and focusing on that workflow made it more difficult. Was that just because of the external pressures and you guys switching to that overhead underground conversion, or do you think it would have been better to start by just big bang doing it all at once?
Are you talking about like focusing on building out, configuring AUD in underground first? Is that what you're referring to?
Figure out 10K underground and then kind of shift it to overhead, and that was really painful.
Okay, well, let me kind of explain that a little bit. So that's actually because the program that was driving the AUD project at the time, right, was almost all underground. Well, the program switched gears because of regulatory pressure, right? So they wanted us to do more overhead, so now we have overhead system hardening with underground as well. So it's kind of a blend, but we kind of foresaw a lot of that up front, like potentially happening. So we did do a lot of system hardening type of activities, but we just probably didn't hit it as hard as we should
We're
have.
playing catch-up now.
Yeah.
Robbie, we're playing catch-up.
It seemed like that would work great, like starting the workflow and building out from there versus like, we're going to replace everything. That seems like a much more common approach.
Yeah, it was also less complicated underground than overhead.
Yeah, I would add that if we had had more of an emphasis on overhead to begin with, we would have identified the issues relating to the DAB with those overhead, and so we wouldn't be quite in the scramble that we are now to try and get those DABs together to make the overhead materials and that stuff functional. So we may not have had to do a whole lot earlier, but just getting visibility on the state of the overhead framing DABs, if we had just gotten that ball started sooner, I think we would have reduced some timelines.
That might have added to our overall deployment time, though,
Yeah,
right? 3 months, 6 months, something like that.
and we were already a little bit delayed.
Yeah.
Of course, Pat, yeah?
Two questions. One statement. We started with the 10K underground, and I mean, that was the focus. What was really actually pretty nice, you kind of saw the problem beforehand, but with it, we were able to get this system up and running under a year. I mean, it was, that PG&E was fantastic to work with. It was, tell me what the problem is, here it is, and we were able to stay laser focused on underground. And then, that's when we were like, well, why are you drawing that too? You already have the trenches simple profile, you got this, why don't you just push this button? And so it's a really good learning on both sides how things work. So that was my statement. Now my question. Your growth in underground, the number of designs, are you able to get this by efficiency, or are you having to get it by hiring out there, or the little mix of going from 100 to 300 to
We know there's going to be a learning curve with our internal resources, so there's going to be a heavy reliance on contractors. We're not bringing on more people, but what we're hoping is this way of work, we're going to get everybody in it for a year, and then they get familiar, and hopefully we can ramp down our contracting, and our internal resources will then be more trained up.
we hope the contractors keep their license.
Well, I think, let me add on that too. So this is like an important part of like understanding where we're trim and fat and not, right? So we are starting to track metrics around not only our efficiencies in AUD, which are still premature because our project cycle times are, quite long for this type of work. We're not churning stuff over. So to get a full data set for a project takes time. And we haven't had a lot of that stuff come through yet. Plus, to track it at a very granular level, you kind of almost need to build in a manual process somewhere to do that. And if it's not easily adoptable, it's not going to be used. But then also, the efficiency of AUD is not only highlighted in the design phase, but it's downstream. Like, there's heavy implications downstream of improving construction timelines, communication timelines, especially with the mobile as-built solution, and really, if you're building these things to standard, then there isn't a need for a lot of design changes, right? Because everything's built to standard. So the argument of you just want to do that for a preference becomes a better argument from the design perspective, right?
So do you also mean by the count of jobs that we get through AUD, Pat? Yeah. So we've already been talking about how we can apply this to different workflows and what steps do we, again, SBS did a great job of asking the right questions, getting us to think about what's the next step. And so now we're looking at other workflows to say, can we apply this tool to other workflows? Because what Jason said, the project life cycle is so long on the larger projects we intended to use this for, that now we have a gap of time and a user till they get the next job. So we're trying to do a couple of things. One is get that user just to use AUD for drafting for now on those projects that are non-AUD. And the next thing is to get smaller projects into it if we can. How can we take AUD and make it, utilize it, I should say, for more workflows to get those number of jobs processed through AUD much higher?
Yeah, I actually was going to mention that too, from a lessons learned. That would be one of the lessons learned, is have small work available that you can churn through to test. All right, thank you very much.
Thank you.
You, Mr. Director,